Greetings. In this video, I want to look at how circles relate to each other. I have circle C and circle E here. They have different diameters. This one is smaller than this one. If we were to pick up circle C and place it inside circle E, we might be able to get the idea that if you multiply the radius of circle C by some number, that you would get circle E's radius. So if we have some distance, which will be the radius for circle C, and we multiply it by some real number, then we should be able to get this segment to be enlarged by this scaling process to be the radius for circle E. The idea of being able to multiply a side by some scaling factor to get a larger side is an argument that we use with polygons, and it is part of the definitional argument that we would use to show that a polygon is similar to another polygon. The other piece of information that we would want in polygons is to demonstrate that all the angles between the two have corresponding congruent angles. We want to get an idea that these two circles are similar to each other. And setting them inside of each other, looking at the concentric circles, we get the idea that it's easy to see that you could just scale up the radius to get the second radius. So go from the smaller radius to the larger radius. Is it just going to work for these two circles, or will it work for other circles? I'm going to start with a conjecture. The conjecture that I would like to make is that all circles in the plane are similar. A conjecture is a statement that we'd like to make about a mathematical observation that we believe is true, but we have not proven yet. I want to go into the next step of that and actually proving this statement. And we are going to use this diagram to do that. I have circle C and circle E. In the diagram, they appear to be different circles. I've given no measurements for these circles. We are just taking them as givens. The first thing that I'm going to do is I'm going to run a line through the two centers. Now, according to the postulates that we have for plane geometry, between any two points is a line. So we can make this construction. So we've now constructed our line by using that postulate. The next thing that I would like to do is I would like to create the diameters in each of these circles that will be perpendicular to the line that I have just constructed. According to the perpendicular postulate, there is a unique perpendicular to this line through each of these given points. We have these perpendiculars through here. This is going to be 90 degrees here. Definition of perpendicular lines. These two lines are being cut by this line, which means that the line that I constructed first is the transversal of these two lines. My corresponding angles here are congruent, which means by the converse of corresponding angles postulate that these two lines are actually parallel to each other, and I'm going to make a parallel indicator on here and here. The intersection of this perpendicular with the circle and this perpendicular with the circle creates 2 points. And since we have 2 points, that means that we can define another line here by the same postulate that we used to create the first line. So I want to create that second line between this point and this point of intersection of the two diameters that are perpendicular to my original line. Now, I want to notice that this original line and this new line will intersect down here. Also observe that in this region here we have a triangle, and from here to here is another larger triangle, so we have a smaller triangle inside of a larger triangle. This angle here is a shared angle between the two triangles. This angle here is going to be 90 degrees since we created a perpendicular here. This will also be a 90-degree angle since we created a perpendicular here. So we have this angle and this angle and this angle and this angle are two congruent angles between the two triangles. So this angle and this angle are actually going to be congruent to each other also by the third angles theorem. So that shows me that the smaller angle and the larger angle have corresponding congruent angles. This is the first step for similarity of polygons to be similar. The second part of that definition, we have to show that the sides of the smaller triangle here are in proportion to the larger triangle here. By the angle-angle similarity postulate, we have that these two triangles are in fact similar triangles. Since the two triangles are similar and their shared bases are proportional to each other, we have shown that this radius and this radius is in fact proportional between the two circles, and therefore this circle and this circle are similar to each other. Now we can write that out in a formal 2-column proof, or you can put that into a flow chart or into a paragraph or a couple of paragraphs as you write out the style of proof that you need. Since we have a formal logical proof now, we can change this from conjecture to theorem. And that is how we progress from a conjecture to a theorem in mathematics. Now that we have a proof for this statement, it is a theorem. It was proven in general, so it wasn't a specific set of circles with specific measurements. It was just any two circles in general are going to be similar. And this is our theorem. Cheerful calculations.